Continue this video, we will talk about priority queue and DAC. So you can see here, DAC actually is inherited from the queue. Priority queue is inherited from the queue as well. So the DAC actually support element insert and remove at both ends. Right, so remember before when we do the priority, when we do the queue, on queue you only can do the first in, first out order. So that's why we add to the end, but we remove from the beginning. But now when we have the queue inherited from the collection, and the DAC inherited from the queue, and also linked list actually is inherited from the list and the DAC. So while linked list, we can add beginning, remove beginning, add last, remove last. That's because the DAC. So DAC support element insertion and removal from the both ends. So the DAC interface, right, extended from the queue, but we add additional method. That's why we can add first, remove first, add last, remove last. Can get first, get last. So that's all defined from the DAC interface. And also again, DAC, remember from earlier our hierarchic picture, the DAC actually still is the interface. So the DAC can be the data type, but cannot create the concrete object. So here when we're using the DAC, but we create the linked list as a concrete object. So we're still using the offer. But as long as your DAC size greater than 1, so we see here, we can remove the last. We can remove the first. So that's why you see Oklahoma, Texas, Indiana, and Georgia. So they can do both sides. It's not like the queue, they only can remove. So they remove from the beginning. So the same thing, the next question is, when you see this example, can I using the iterator to traverse the DAC? Yeah, you can, but still the same thing. Remember, your DAC inherited from the queue, so you only can use the iterator. Okay, so that's the DAC example. So how about the priority queue? We heard about priority queue before. Priority queue actually is one kind of queue because we inherited from the queue. So the priority queue, by default, the priority queue order, that's we follow the first in, first out. But they also have the first out according to the value for the element. So the priority queue order is element according to their nature order using the comparable. So that means depends on the data type you save in the priority queue. If we don't specify, we check if this data they save, they implement the comparable interface or not. So they will call the compare to do the sorted order. So the element with the least value is assigned to the highest priority. So on the other hand, the priority queue by default in Java, we do the low to high order. However, if your data, the object, they didn't implement comparable interface, right? So that's why you can specify an order using the comparator. So you can either overwrite, so not really overwrite, using different comparator. Okay, so they will using the specific comparator you specify. So regardless, the value object they have the comparable interface implement or not. So that's why in the priority queue constructor, you can see they can specify the comparator. So you can see priority queue, you have empty constructor, or you can initialize the capacity, or you can create from the existing collection, or you can specify your initial capacity with the comparator you want to work on to create your priority queue. So that's why here that see our priority queue. So priority queue actually is the concrete class. So that's why we can using the new to create the object. So the same thing, we still add those 4 city one by one. But now because you are priority queue, so that's why here we just using the priority queue. That's by default the comparator because the data type is string. So string definitely implement the comparable. So that's why we will see here they will, when you try to remove one by one, so their order will be in the alphabetic order. So that's why you see the priority queue is Georgia, Indiana, Oklahoma, Texas. So they are using the low to high order. So now we also can create our priority queue. The same thing, we still add these 4 city. But now you see here, we're using the reverse order. What is reverse order? Yeah, we're back to see the static method. So earlier we have the static method from the collection, right? So you can see here you have one is we call the reverse order. So they will return a comparator. So the comparator actually is according to the originally comparator comparable how you implement that, they reverse that order. So on the other hand, if originally when the string we implement compared to, we're using the low to high order. So if we do the reverse order, right, so then they will do the high to low. So that's why here on this one is, actually we need to recreate the priority queue. So priority queue, if you want to specify your comparator, they only have the constructor, they need to specify your initial capacity with the comparator. So we use the reverse order. So that's why even you still add the city one by one like that, but the comparator actually reverse order. So when you try to print one by one, they will do the descending order in the alphabetic order. So the same thing for the remove, when you call that in the queue or a deck or a priority queue, they all follow the order. They need to follow the first in, first out order. Additional to the priority queue, they will according to the comparable order. However, they still can using the iterator to traverse the element one by one to see how the collection inside their order is. But I just still want to remind you, you can use the iterator, but because the priority queue inherited from the queue, so that's why they only can use the iterator instead of the list iterator. So that's our priority queue.